If two Jupiters collided, the energy released would be greater than what the Sun produces in 10 million years, in a single moment. Let that sink in for a second. Two planets, each large enough to fit 1,300 Earths inside, slamming into each other at full speed. This scenario sounds insane, but it's a perfect thought experiment for understanding the physics of gas giants. Jupiter is already a monster on its own. It has 2.5 times the total mass of all the other planets in the solar system combined. The storm known as the Great Red Spot is wide enough to swallow 3 Earths, and it's been raging for at least 350 years. But what if there were a second Jupiter, and the two were traveling in opposite orbits and met head-on? That's where astrophysics turns into a cosmic horror movie. In this video, we'll break down that collision second by second, what happens, what it causes, and what's left behind. First, let's get one thing straight. Jupiter doesn't have a surface. There's no solid ground. As you descend deeper into its atmosphere, the gas gets denser, turns into liquid, and eventually becomes metallic hydrogen. This substance doesn't exist naturally on Earth. It can only form under the extreme pressure found inside planetary cores. So a collision between two Jupiters shouldn't be thought of as two rocks smashing together. It's more like two ocean-sized liquid masses plowing into each other at hundreds of thousands of miles per hour. There's no bouncing or shattering on a solid surface. Instead, the two masses sink into each other. In the first minutes of the collision, the atmospheres begin to mix. Massive shock waves tear through both planets. The temperature? It spikes to tens of thousands of degrees Fahrenheit. Let me put that in perspective. The surface temperature of the Sun is about 10,000 degrees Fahrenheit. The point of impact easily surpasses that. And at those temperatures, hydrogen gas turns into plasma, the fourth state of matter, that strange glowing state found inside stars. Hold on, let me explain this a bit more. A shock wave is a pressure front that moves faster than sound itself can travel. When it reaches the metallic hydrogen layer inside Jupiter, that layer is conductive, so it generates enormous electrical currents. The magnetic field goes haywire. Normally, Jupiter's magnetic field is 20,000 times stronger than Earth's. At the moment of collision, that value becomes impossible to calculate. Radio waves blast outward with such intensity that a sensitive enough telescope could detect them from the other side of the galaxy. So what's left behind? Simulations show a few possible outcomes. If the collision is head-on and at high speed, a significant portion of the mass gets scattered into space. Trillions of tons of hydrogen and helium gas are flung outward, forming a temporary cloud resembling a nebula. As this cloud cools, it condenses, and maybe, just maybe, new smaller planets could be born from within it. The remaining material collapses under the ruthless pull of gravity and merges into a single mass. Here's the critical question. What happens to that merged mass? The combined mass of two Jupiters is roughly 0.2% of the Sun's mass. That's not enough to become a star. You need at least 80 Jupiter masses to ignite nuclear fusion. But the mass we're left with could be enough to form a brown dwarf, a dim, hot celestial body stuck somewhere between a star and a planet. Some call them failed stars. They can't produce their own light, but their surface temperature can still remain above 1,000 degrees Fahrenheit. Not quite a planet, not quite a star. Think of it as the middle child of the universe. Still, the resulting object would be anything but ordinary. The energy from the collision is so immense that the newly formed body would emit infrared light for thousands of years. If you looked at it through a telescope, it would glow faintly like a dying ember. Now think about the impact on the surrounding environment. If this collision happened in our solar system, Earth's orbit would be in serious danger. Jupiter's gravity is already the key factor that maintains the balance between Mars and the asteroids. The sudden displacement of two Jupiter masses could throw the inner planets' orbits into chaos. Over millions of years, some planets might fall into the Sun, while others could be flung out of the system entirely. And don't forget the debris cloud from the collision. Gas and dust particles raining down on Earth could alter the atmosphere and block sunlight for weeks. Remember the asteroid that wiped out the dinosaurs? That impact was caused by a rock roughly 6 miles across. Now replace that with a gas cloud weighing trillions of tons. The comparison is almost laughable. Is all of this purely theoretical? Not entirely. Astronomers have already observed traces of planetary collisions in young star systems. Unexplained hotspots and irregular brightness fluctuations in the dust disks around certain stars could be evidence of exactly these kinds of events. In 2021, a research team reported an infrared flare believed to be the remnant of a collision between two giant planets. The two-Jupiter collision scenario isn't science fiction. Statistically, it's an event that has happened countless times across the universe. Maybe right now, billions of light years away, a collision just like this is taking place, and we simply haven't seen its light yet. Here's the bottom line. The concept of scale in the universe is beyond human imagination. The collision of two gas giants isn't just a single explosion. It's an energy display lasting centuries that would put stars to shame. It destroys planets, creates new objects, and completely reshapes the fate of a star system. And we can only imagine it through physics equations and computer simulations. But only for now. If you enjoyed this video, don't forget to subscribe and leave a comment. Do you think a collision like this could be happening somewhere in the universe right now? I'd love to hear your thoughts. See you next time.